Hello and welcome to another video with Rise Up, Don't Run Math. In this video, we're going to go over some common geometric vocabulary and look at some examples of how it might be used. There's a few words that are building blocks for everything in geometry that we're going to start by defining. The first of those building blocks is, what is a point? So a point is an exact location on any sort of surface. It's not a thing but a place, and it has no size. So although we draw it and we represent it with the size, it doesn't actually take up space. It just tells us where something is. So the way that we would draw a point, and we label it with a letter, a capitalized letter. So I might say point A, or point C, point L, and so on. When we're describing this, if we were to write it on a paper, we would call it point A, point C, and so on. So once we start to use this building block of a point, it allows us to have all these other types of geometric figures that we use. The first of those figures is a line. So a line I'm sure you're very familiar with from algebra, but a line's definition is a figure that holds no thickness and it extends infinitely in both directions. So a line is created by taking a bunch of points and thinking about the spaces between them. So if I have point A and point L, I can connect those two to form a line. But really this line is a connection of all of the points between them. Maybe there's a point M or a point Q, and all of these little points, as I connect them, start to form a line. In geometry, the way that we notate this is we pick two letters off of that line. So it could be any of the four that I have there. I have A, M, Q, L, or I could put another point with a name on there. I'll go with AQ. So point AQ, points A and Q, and to show this is a line, I draw a line above it and I put arrows on the ends to show that it continues in both directions. Notice I didn't need to put the points on there. The arrows tell me that it's a line. You could also reverse the order of this and say QA, or you could use different letters entirely. So I could say MQ with my arrow above. So that makes a line. The next type of figure we're going to talk about is called a ray. So a ray is a part of a line with one endpoint, and it goes infinitely in one direction. So let's take a look still at that same sort of line that we started with. We had line AQ. Well, a ray tells me instead of going in both directions, it's only going to go in one direction. So let's say I start at point A, and here's my point Q. One ray could be to start at A, to go through Q, and to keep going forever. The way we would name this ray would be A, Q, and we're only going to put an arrow on this one side. And so Q is the side that it's going towards, so it gets the arrow there. A different ray that I could have made, which would be different from this one, would be, what if Q was my end point instead of A? So what if it ended at Q and kept going forever in the direction towards A? So the way that we would name this ray is we always start with the end point. So if we look in our previous example, A was our end point. Now Q is the end point. A went first here. So now Q is going to go first. So I'm going to say Q, A, and my arrow goes to the right. So even though my arrow is pointing left on the diagram, when we notate it, so this is how we would write it on our paper, the arrow will always go to the right. So for our next example, for our next type of figure, is a line segment. So the segment is the part of a line and it connects two endpoints. So it stops in both directions. So if we take our same example, we had point A and we had point Q, a line segment just connects them and stops on both sides, so it doesn't continue. The way that we notate this is we use our two our 2 points, and we put a line above them, and there's no arrows, and that means that it stops. Notice I didn't need to put a point on either of the ends there. I could also reverse our lettering just like we did previously, and this one would be QA. So the lettering can be reversed on a line segment because it's still describing, it stops on both sides. It's describing the same segment. The next geometric figure that we're going to talk about is a plane. So a plane is a flat surface that is infinitely large and has 0 thickness. So it just shows a surface that things exist in. And it is represented by a shape that usually looks like a floor or wall. So kind of make it look like a floor. And to make a plane, you have to have at least 3 points that are existing on that plane. So theirs could be 3 points. And just like before, I can give them a name if I wanted to. This could be point A, B, C, and so on. So a plane is a 2-dimensional surface. So now we have 2 words that are very similar, collinear and coplanar. So collinear means points that lie on the same line. So for instance, when we did our example above, where I had the multiple points there, creating our line, points A, M, Q, and L are collinear because they're on the same line. Coplanar in that sense means that points that lie on the same plane. So for instance, the way I want you to maybe think about this is if you're standing on the floor of a room, anyone's feet that are on that floor would be coplanar. But if someone had their feet kicked up on a chair, they would not be on the plane. They would be not coplanar. So what this might look like if you saw it drawn on a geometric diagram is like, here's everyone's feet on the floor. These are our points, A, B, and C. There could exist a point above that plane. Maybe this is point D. And so that would not be coplanar, because even if I extend this plane in each direction, this point is above the plane. So it will never touch that plane. So that's what coplanar means. So let's go ahead and take a look at some examples of how this might turn out in geometry class. So it says in the diagram of collinear points, find the indicated measures. So anytime you're saying something, it's measure, we drop all of this notation because we're saying what number it would equal, and this is just its name, AQ, line segment AQ. If I'm giving you its measure, I'm telling you what it's, when you measure that, what it equals. So it's different than its name. So they're telling us in this particular problem that GW measures 19. So if I look, G is here, W is here. So the length between them, and I always like to draw it like this on the outside, would be 19. It tells us GL is going to equal GO. And in geometry class, the way that we mark things are equal is we put these tick marks. This is measured the same as that. So I'm going to put those tick marks there, and you'll see this come up more, but those are going to be the same. And then they tell us that LO, so point L is here, O is here, is 6. And they want us to find some other measures. So the first measure they want us to find is GL. So GL is right here. And because we saw that it's the same as LO, it must also be 6. The next one that they want us to find is GO. So I want to find point G and O. So here is G, here is O. Well, that full distance, if I add them together, must be 12. And lastly, they want us to find WO. Well, I know that this part is 6. This part is 6, and the full thing must be 19. So if I did 19 minus 6, or I could just do minus 12. So we have 7. And so OW is 7. And so 7 would go here. Anytime you find a measure, it can usually be helpful to write it on the diagram in case you need it for something else. So that's a habit I try to be in. I hope this video has helped you understand some of the common geometric vocabulary and how you might see it in future examples. Thanks for listening.